What we went over on rotational volume like a week and a half ago before we took our test. Okay. So when we left off, we had discussed how the volume formula of a cylinder can be changed, right? We had our x-axis is like right through the center of the cylinder, and the normal volume formula pi r squared h. Here's my radius of the circle, right? The h was how wide the shape was, right? And we discussed how if we take the h and we split it into like a bunch of tiny cylinders, and I take one of those cylinders, and that's like a Riemann sum rectangle, right? That's been spun around the x-axis. And if we can make those Riemann sum cylinders teeny tiny wide, right? Then that's like our dx value. So we said, well, if I want to go from A to B, right, and integrate to dx, that's taking infinitely small wedges, right, next to each other. But instead of the same radius, right, we had like an f of x function. So each r length was changing. So that was where our f of x came in. So that's my r squared h, and then times pi to find the volume of any object that's been rotated around the x-axis. Does that jog your memory? Okay. And then we have, I have the special paper to show it to you, yeah. Okay, so let's see if we can remember this. And I want you to I want you to find the volume if this shape from 0 to 2, y equals x squared plus 1, that region, I want you to rotate it around the x-axis. What would that look like? Like a tree stump, maybe. Yeah. A nuclear power plant. Yeah, the stacks. Is that what they call them? The stacks where the smoke comes out, maybe? I don't know, stacks or chin. I don't know. Anyway, you get the idea, right? Okay, so go ahead and find the volume of that to 3 decimals. And then that'll review what we did right before the test. And then we're going to build on it today. And find the green one. Go ahead.
Emily Mosberry and Mandy Bash.
She's not here. Mandy's not here.
And yeah, you get a treat.
Find the green one then.
Thank you.
I have to square it. It's like cylinder of comics and stuff. I thought she was doing no, because it was like infinite cylinders. I got you.
Oh, okay. I just thought I heard you guys say you were doing the 2 first, and so I was just coming over to make sure you were doing the 2 first. Oh, no, that's fine. Yeah, there you go. Go crazy. Don't forget to square. For your R squared. And you definitely want to change your 0 to 2, but you also forgot your
I'm
square.
actually not.
Yeah. It doesn't matter which direction, clockwise or counterclockwise. I'm just showing you where it's rotating around. Because it's not always going to be the x-axis. We're going to do different ones today. Yeah. So, but it doesn't matter if it's clockwise or counterclockwise. That won't matter. All right. Did you guys? Can someone who got the black one raise their hand and tell me what they got? What'd you get?
I got 43.145.
Okay.
Yes.
0 to 2 pi x squared plus 1 squared dx, right?
Yeah.
And then the green one. 6.283. Okay. Now, first of all, I'm going to tell you a little story. Guys, focus here. We're going to, I want to kind of, I don't know. We're going to talk about something and then I'll show you how it relates to this, okay? Does anyone in here, any of our real crafty friends ever made any homemade beads out of clay? Anybody ever done that before? Okay. Yeah, a lot of people do. Yeah, so the idea is you can take clay of different colors and some people like to marble it up and then they roll it in a ball, right? And then you have to let it dry a little bit, but not all the way. But then once you've made your shape that you're going to make the bead out of, then you go in with a drill or a punch or something and you take out the center of where you're going to put the string through. If you wait till it dries all the way, then it might be brittle, it might crack, okay? But if you don't wait long enough until it hardens a little, then it's not going to maintain its shape. And the whole point of making a homemade bead is that you want it to maintain a certain shape, okay? What about going to Krispy Kreme donuts? Anybody gone there when the sign says hot and ready? Oh, a few of you perked right up when I said Krispy Kreme, huh? Okay, so when you go to Krispy Kreme donuts, it's not like they take a roll of dough and then bring it around and connect it here. If they did that, you'd see a seam in the dough, right? Where they tried to connect them, and every once in a while you'd have some that would pop open, right? It's not how they make a donut. They make the full volume of the donut. Then sometimes if they're going to make like a Boston cream, they'll fill it then. But for most of them, once they make the volume of the donut, then they take a punch or a cookie cutter and take out the inside, right? If I have the volume of something, right, and I want to maintain its shape, right, then I have to take a volume out after I've made the volume that I want, right? I'm going to keep that in mind for this next question, okay? Now here...
I think I did an explanation with like the physical donut.
Yeah, who's going to pay for that? You? Yeah. Okay, now I want you to take this and instead of... I want you to imagine this is like a shovel or something that I'm taking it out.
Whoa.
Okay? So hold on. What you see is I have this pink area here, right? And that is what I want to rotate around the x-axis. Okay, you see that? That's that, right? Okay, so if I take that, it's gonna look something like this. Yeah. But you see how it's like, if you look from this side, it doesn't look any different from the first one that we did, right? But it should have a little something, right, dug out of it. Does that make sense? Okay? Now, what I want you to do is I want you to see if you can think about the kind of story, I don't know what else to call it. I told you about like the clay beads and the donuts. Basically, I want to know, how do I find the volume of this, right? The volume of that shaded region, okay, rotated around the x-axis, okay? Answer is fine, but I care more about the integral expression, okay? So I'm going to see if you can figure it out with your neighbors. Go ahead. Is it that you want to play with the paper?
I'll draw on the graph.
Yeah, I was like, I just realized that. What you have to do right now is add everything that we're going to do. So if you want to try and combine it into a single integram,
Except when our technique looks like that, I say
yeah. And now I understand what you meant by the one focus. Yeah, I get it.
Maybe that's it. So she's definitely
this is where we stopped last time.
Okay, so here's what I'm going to put. Excuse me.
But normally you guys
Oh yeah, when there's four, she does it.
no, in Millie's
What are these, by the way?
Marble roller coasters out of parabolas. They have to write the equation of each different color on their roller coaster.
That's awesome.
Yeah.
we had a whole discussion.
What is it?
Yeah, why don't we just leave it like this?
What is it?
Secondary two.
I'm gonna stand here for
All right. I want to talk about these two things. My guess is that as you guys were working with your neighbors, you got one of those are the exact same thing. What the heck am I doing?
Yeah,
I don't know, I was gonna say.
This is what I meant to do. Okay, my guess is that you got one of those two things, right? Is that you're thinking of either one of those, right? Now, first of all, my question is, are those the same thing?
No.
Yeah, Miss Christensen last year, if you had her, she would have called that bad math. You can't distribute an exponent. Distributive property is specifically for multiplication, right? These are not the same thing, just like 1 plus 2 squared is not the same thing as 1 squared plus 2 squared. Yeah, I do too. Because then the bane of my math teacher existence would go away. Because that's something we're always getting wrong. The other one that drives me absolutely bonkers is this one. These are the two that my students will always mess up. They want to be like,
Bro, what?
I'm like, yeah, you've all done it. You've all done it. Don't give me that look. You've all done it. Let's get the test folders. You want to make a bet? You've all done it. Okay? Okay. All right. You've all done it. Anyway, moving on. Okay, now, one of these, you guys hold on. One of these is, which one's smaller? Which one's going to be smaller?
The green.
Why don't you talk about it with your neighbors, do some exploration in your calculator. Which one's smaller and why? Which one's going to be a smaller value and why?
Are you talking about the?
Try it on your
Are you
calculators.
talking about those equations or the?
No, of these two.
Of these two?
We're
Okay.
focusing only on these two right now.
I think it's-
The first one is separate ones. Separate rectangles. The other one's like a whole new deal.
Why need like 8 parentheses?
Why do you think it's wild?
So I don't have to worry about it. Because so I don't have to worry about it and I don't forget that it goes with the whole thing. So I just don't like over parentheses.
I mean, it's like those.
It's average. You know, it's average.
Hey, come back. I want to know which one's smaller, but like normal, I want to know why. That's more important to me. Kind of explain it with the math conceptually. Why is one of those going to be smaller than the other? Anyone have any thoughts? Okay, yeah.
So, this bottom one is going to be smaller because instead of having a number and squaring it like this, once it's squared, it's going to be a bigger number, right? And then you're going to like do that with the other one. But since this number is going to be bigger than just this number, the difference between these numbers would be greater than the distance between these numbers.
Exactly. When I take the things and subtract them, this is going to make a small, perfect, Carrie, thank you. This is going to make a smaller number, right, before I square it, right? This one, you're squaring these to be much bigger numbers and then subtracting them. This situation is always going to be smaller than this one, okay? Has to be. Think of it. 25 minus 9 is 16, right? What's 5 minus 3? 2 squared, 4. Right? When you make the numbers much bigger first, okay, then they're always going to be bigger when you subtract them is if you subtract first, okay? Now, hold on. Which one of these, and raise your hand and tell me why, which one of these is going to represent our pink solid shape, okay? Amelia,
The top one.
why?
Because you're taking the two volumes like separately and then subtracting it instead of like it's two separate integrals squished together, so you have to have the volume of f of x and the volume of g of x.
It's like I'm saying what?
But the don't.
What do you mean?
You got full volume first.
Full volume first. If I want to maintain the shape of this pink region, right? Don't I need this coordinate up here needs to have a radius of 5 or a diameter of 10 for the whole object, right? Well, that's not happening here. This is actually going to create a whole new shape. It's not maintaining the shape at all. What this is going to do is create a new shape where all of these distances are laid out on the axis and spun. Does that make sense? What this one's going to do is keep the shape that I want for each outline, right? Each boundary in the 3D object. Okay? Volumes first, then subtract. Has to be. Okay? So that tells me that on this one, that's the answer. Do you see?
Yes, I get it.
Okay, and if you type in, if I remember, what is it, 36 point,
861.
okay. How are we doing? We doing okay?
Yeah.
Any questions? Okay, we're gonna try a couple examples and then move on.
Which for you?
Me?
No.
Oh yeah?
It's loading. It's loading. Yeah. I was like,
Look, does it have 4 dots like that up there, or are they?
it's loading.
Oh, yours is different. Okay.
It probably is the same thing as Magic.
Okay. Enter.
You accidentally pause.
They literally don't say anything about our competitors. It's like, hey, not even emails like this. I just find out. Competitors say, I was like, what? Try to go on Friday.
Hey guys, go ahead.
Yeah.
Why?
So they let me first. I mean,
I feel like if our school was more attention.
only like the area.
Hey guys, you're trying them, right?
Yeah.
In my head, they sound like Scarlet.
Wait.
Hey, we're gonna try these with your neighbors. The second one is gonna jog your memory a little bit from what we did before our test. I wanna see if you can make the connection without me explaining it to you. And sign the log over there.
Oh, I actually really like it.
Yeah.
My memory prefers walking instead of jogging. So
Oh, good one. Jogging your memory.
That was
Yeah, that is actually pretty clever. I haven't heard that before. I gotta think. I need some time to think of a witty comeback. I need a minute to think of some witty comeback. So say that joke again in like 10 minutes.
okay, yeah, I got you. I'll be like on a totally different topic. I'll be like, hey, I've got something I need to say.
Yeah, I like it. That's a good one. I haven't heard before, so I have to think of a good witty comeback.
just clear it all up.
I gave you the
Oh my god.
I'm about to start fighting.
Just that first one.
I'm joking. That's so bad.
Okay. You need to write an integrated answer.
Oh yeah, I always forget to
Petition to get
Just go to it. You just light up the room. That's a lie. What the heck? You are strong. You're one of the strongest people I know. Your strongest person is a ghost. That's really says something about you.
Wait, I have a question.
Mm-hmm.
Oh no.
Okay, I found it in a test.
Your ingredients.
I feel like there's only a better one for like I don't know.
Well, then you didn't figure it out. Joe figured it out.
Fixed
I
it.
heard that.
Fixed it. We're good.
Handball.
Is that what we're trying to find?
Yeah, we don't know.
Wait, graph it and see where they
No, I already did that, but it's in decimal form.
Yeah.
And trig form.
No, I did.
So it's like
On the other Oh, that's kind of
Do you guys need a hint for number 2 yet?
No.
Okay.
That's a little awkward. You just, I try something equal to each other, but I'm already like,
How do you do this?
I like the X out. No, try not, no, I said them equal to each other. Just try to find out.
Oh.
Well, yeah, but like, if I cosine X, you can get X out of it. What else is, wait, how else are we supposed to find that?
Graph calculus section.
I did, oh yeah, but then I got like a big decimal number. I thought I should do it. I mean, well, I just, oh, I already did that. I got like X equals something. I don't know if I can do that.
Yeah, you keep the whole decimal and you don't do any fractions on the end. So that's why I showed you guys how to do the storing thing. What?
So 0 to 6.
I'm so confused.
Okay, we found that, and now.
Oh, we're rotating around the axis. I thought we were rotating along the other graph. I was like,
Which one did you use first? The inverse cosine, the inverse sine?
0.6. No, I got 0.6.
But your,
Well, yeah, but I didn't have
got limits in your index.
I mean, fair.
Oh, I guess they should be different because they're not even the same equations anyway.
So pi first.
oh wait.
Wait, so their intersection is basically just
0 to 0.6.
I guess they're different numbers.
Yeah.
They shouldn't have put the P here. Appreciate you. If they just put A, it makes more sense. A, appreciate you. That is saying something, especially the big bubble wrap. Okay, you have more time, but can I have a volunteer come up and write the first one?
Sure. So, I got this.
Awesome, Michael. Good work.
If you cut it, don't
These aren't very nice. You wrote don't in front of all of these. Put these in the swear jar. These are going in the naughty jar.
it'll be like a time. It'll be like a
Yes.
Yeah, don't hear anything. Yeah. Cool.
Okay, is it 0.31 exactly? You got up 3 decimals. What's the third?
I got that's the third one.
I thought those were absolute value bars.
1.1. No.
I was like, why did you put absolute value bars? I mean, okay.
No.
Yeah.
Well,
Yeah. Okay, there we go.
I guess that makes sense.
No, there you go.
It really changes.
No, so I was just gonna let it keep it, but anyway, that was weird. Is that what you guys got?
Wait, hold on.
Looks good.
You made me.
Okay, but look at it. It kind of looks like absolute value bar.
No, it does. No,
Yeah. Okay. I was like, why
no.
do you put absolute value? Okay.
No, you're right. You're right.
Okay. No, it's 1.311. Perfect. Okay.
Gaslighting me. I was like,
Any questions?
Oh, I know.
Yeah.
Okay. Now I want you to look at the second one. Do you guys need more time to try the second one? Okay, I'm gonna give you more time, but I'm gonna give you a hint. Notice that it says this time it's rotated around the y-axis, not the x-axis.
That changes things.
So you should be doing dy. dy, meaning what's the first thing I should do? Get X alone. Switch or rearrange the equations. Get X alone. Okay.
Don't ask. It's not the reciprocal, it's the inverse.
Yep, correct. It is not the reciprocal, it is the inverse. Reciprocal is secant, cosecant. We're doing arc. Arc sine, arc cosine. And remember, you're not actually switching X and Y. We're not actually finding the inverse. We're just rearranging it. So X is alone instead of Y.
That's what I'm telling you.
He is a psychopath.
Hey.
Oh, I know I'm crazy. Crazy could be fun. Yeah.
No, this is where I use
Lame.
That.
Got it. And then. Wait, so when I'm. It's fine, it's fine. No.
Yeah, sure.
I'm
Alright, that's just. I'm not even. No, just grab it. So I'm just trying to find the intersections, right?
So if when you have to do these
Let's see, so.
Oh, wait, it's gonna go.
if you wanted to try putting a number in,
Oh, y equals. Oh, okay,
So I
that
think
makes
it-
sense.
comparing the
So I use
outputs, again,
0.7
without a calculator, that would be hard to do because what number is going to be nice for an exponential number?
0.707.
So on these ones that have a little bit more complicated situation going on, I would probably just do that. And when we have to figure that out by hand, they're usually more basic, like a trig or a polynomial or more easier functions to deal with.
That feels like fun to me.
1/3 calculation. Alright. Can I have somebody come up and write what they got for number 2? Can I have someone? Sid? Sid got there first.
Wait, wasn't that
So feel bad. Computer's in here and doesn't plug it.
How would I put it dy or like use y like calculate?
Sorry, I'll talk about it. Dang, you went all the decimals.
There's no intermediate rounding column.
Next to the y coordinate.
But you can do 3. But probably has to
No,
do
there's no
Yeah,
intermediate
that's what
rounding.
we're do. Because you're in the habit
We
of
just
using
talking
it.
about this one. I do.
But remember, your calculator will save
No,
that
I'll
y
probably get the
coordinate.
same. I'll probably get off by
Coordinate
2.
is your alpha y. It'll
You just
automatically.
calculator?
It is.
Dude, just talk to the calculator to wake it up.
or maybe I'm just wrong.
So press. You don't have to. That's what I'm saying. Your calculator automatically saves it into the y.
Yes, that's so
Got it.
Oh, look, I got the
Alpha X
same
alpha y. I've shown you guys that before.
Oh, wait.
Yeah, but whenever you
So,
have intersection,
when you get down,
automatically
like, if you use X, just putting it in the calculator. No, well, when you try to solve it in the calculator, you don't have to.
Okay, I have shown you that
You don't have
at
to
least
figure out
three
what.
Oh, do you
Okay, that makes
Right, that makes sense.
that makes things
Yeah.
easier.
You should have, Josie. She probably used her good calculator. I got that my Spencer. Keep running.
Right to left. So it's like positives to negatives. You're always going from positives to negatives. I couldn't tell based on the reaction. What do you think?
My friend Zach.
That's what I
Oh,
got.
yeah.
Yeah?
Exactly. You know, there's.
I'm
Guys and girls up here?
Yeah.
You agree?
I agree.
Okay, so I want a rule of thumb. How do I know when to do dx versus dy?
When you're rotating the
Depending on which axis you're rotating. Now I'm going to say it a little different, and it's important enough to write down, so I'm going to say it a few times, okay? I'm going to say it a little different, okay? When my, not yet, not ultra level yet. When my axis of rotation is horizontal, use dx. When my axis of rotation is horizontal, use dx. When my axis of rotation is vertical, use dy. When my axis of rotation is vertical, use dy. I'm going to say it one more time. When my axis of rotation is horizontal, use dx. When my axis of rotation is horizontal, use dx. When my axis of rotation is vertical, use dy. When my axis of rotation is vertical, use dy. If you want to hear it again, you have to rewind the tape. I've said it a lot of times today, as you can imagine. Okay? Rewind the tape. Go back in time. Make a time machine. That's actually my favorite response sometimes when people are like, how can I get that homework turned in? Well,
Make a time machine.
make a time machine and get it done before the due date and then turn it in.
But then they won't make a time machine. Because they'll have the homework turned in.
Now that sounds like
Oh.
something Stephen Hawking should answer for me. Okay, well,
They won't have any reason.
what a conundrum.
Stephen Hawking just looked down from heaven and
Yeah, like,
Stephen Hawking just looked down from heaven and applauded. Like a nice slow golf clap. Okay.
Have you seen Tomorrow War with Chris Pratt?
Oh, I have seen that actually. Yeah, that was good.
That's a
If
solid.
they killed the
I don't remember it though. That was one of the first ones I watched in quarantine, so it all gets blurry after that.
Like, other alien, and there's no reason to go back.
Okay. Okay, so now, guys, focus. We're gonna, guys. So now, why didn't I just say x and y axis? Why did I say vertical line, horizontal line? Because we're about to build. Okay, so let me give you our next problem, our next situation. Okay, so let's say I have this y equals x squared plus 1 and y equals square root of x from 0 to 2. Okay, and I rotate this around the x-axis. Okay, now let's say I have these two same equations again. And I want the region between them. Okay, but this time I'm going to okay. Now, I'm rotating it around the line y equals -2. Okay? Now, here's my first question I have for you, and I want you to talk about it with your neighbors. I want to know if these two volumes are going to be the same, why or why not. Okay? Talk with your neighbors, and then I'll take a volunteer.
Yeah, the volume.
They're never, it's never that big.
Oh, wait, same volume, different shape.
Oh, wait, actually. Well, I can see it.
That's like shit. Like it doesn't.
10 seconds and wrap it up.
Actually, yeah. But there's no volume
Yeah.
Or it's different.
It'd still be.
It's the same or it's different. Good call. Great conversation.
I believe
Math scholar over here.
Could be the same or it could be different. Okay. All right, quiet down. Can I have somebody raise their hand and tell me what they thought? Chase, go ahead. Quiet, please.
I guess Josie can go because she said it first. Oh, okay. It's like stretching a donut out because like there'll be a bigger hole in the middle, but the volume will stay the same.
Okay, anybody think? What do you think?
I agree. Same volume, different shape is what I say.
Okay.
I said it.
Kaylin?
I said it.
So, what you have to imagine with the listen, hold on, listen. With the donut idea, when I stretch out the donut, does the donut itself
It's getting smaller.
get smaller, right? That's not what I want to happen here,
It's staying the same.
right? I want the width of the donut to stay the same. Taylin's right on this one. It is a bigger volume, okay? Imagine, you guys, listen, shh, when we did it, imagine when we talked about 3D at first, we said, imagine it like a bunch of cross sections stacked on top of each other. These are just really weird looking CDs, right? In order to get this one to go all the way around, we need more cross sections. I need more volume, or else I'd have to thin this shape out. Does that make sense? Who's a run? Chase, you're a runner in here. Explain to the class why on a racetrack, why do the runners start at different starting positions?
Because if you start in the inside lane, it's a 400-meter track. But if you start like in lane 2 or 3 or 4, like the wider you go, you have to start at a stagger, so that eventually it'll even out on the turns. But you have to start way ahead because if you're way far out, it's gonna be a longer distance.
So the outside track is a longer distance,
Yeah, it's like
even though they start at the same spot. They're the same type of cross section, but the further away they are from the middle of the track, the more track there is. So they have to offset where they start. It's that exact same idea. If I have a larger rotation, right, has to have more volume, okay? I have, like, you can, with my fancy paper here, imagine like when I have it just around the x-axis, you can kind of see how close the honeycombs are to each other, right? Well, now let's say I wanted some space in between those. Do you see how much more spread out the honeycombs are? That's indicating it's taking more length as it goes around. Does that make sense? Okay? So this is a bigger volume than this one. Okay? All right? The only way it would be the same is like with what Josie was saying when you stretch out the donut. But remember, the donut gets thinner and smaller as you stretch it out. If I want it to maintain the same thickness, I'd have to add more dough. Have to. Right? Okay. Now, what I want to know, and this is another, and I'll give you some time to chat with your groups, is can you describe or come up with a different situation of two equations that would have the exact same volume as this situation? Okay? I want to know a different pair of equations, okay? They might be similar but different, okay? That would have the same volume as that second situation. Okay? Talk with your neighbors.
Yeah, but I think she's trying to say that exact same mechanism there.
I want a different pair of equations that would have the same volume as that second situation.
So,
Not necessarily.
Oh, shift both of them.
Yeah, and then white. Or you want to shooting it. It just has to be the same distance away from like where you're
So that one would be like one slot under, and that one would be.
Okay. Anybody have any thoughts? Okay. I've heard from you, Carrie, already today. Anyone who I haven't heard from yet today? Do you need more time to think with your neighbors? Okay, I can give you another 20 seconds.
I was just thinking the first
Okay. Come back. Carter, I want you to explain to the class what I just heard you explaining to your group.
So if you minus 4 from the starting positions of each of them, it gets put below the line again, and when it rotates around, it's the exact same shape.
So, if the idea is what he's saying is if I minus 4 from everything, so I'm taking the whole situation and just shifting it down, right? Then it's going to be the same distance away from its axis of rotation, right? It's going to have the same volume. That's the idea, right? Okay, I heard this group talking about shifting it all down 1 or up 1 or something, right? That's the same idea. If I take every bit of the situation and shift it up or down all the same amount, then the volume and the shape will hold, right? So now I want us to combine that with the easiest way to find volume is my axis of rotation at the 0, right? And after, like what Carter was saying, right, we know that the volume's going to be the same as long as the whole situation is shifted up or down the same amount. So where do I want to shift this situation?
to 0.
To 0.
Up to.
Up to. There we go. Because if I take this graph here, it's going to have exactly the same volume as if I took this whole situation and moved it up to and rotated it around the x-axis. Now I want you to think back to transformations. How do I take a graph and shift it up to? Add 2 just on the end or in by the x?
Yeah.
Yeah, by the x takes the horizontal.
So by adding 2 at the end of each equation, these are new equations, right? But this rotation around 0 will have exactly the same shape and volume as this one around -2.
Yeah, but it's just easier to figure out.
But it's easier to figure out. In fact, I just had to do multiple examples of that, right? So now I know I could take this and go my integral pi 0 to 2 of x squared plus 3 squared minus square root of x plus 2 squared dx, right? I'm going to write this one a little different just because I want to. Okay, do you guys see the idea? I still did dx because y equals -2 is still a horizontal axis of rotation, right? And if I want the axis of rotation to be 0, so it's easier, but I want the shape and volume to maintain, then I just shift the whole situation up 2. How are we doing, okay?
Yes. I get it.
Okay. We doing all right?
Yes.
Okay, because I'm going to ask another question as soon as I remember what it is. Then I'm going to ask it.
It's on its way.
It's in there somewhere. Oh, I do remember now. Okay, so now what if I took same graphs and I want to rotate it around something above it? Is subtracting 5 the only thing that will need to be adjusted? Something else is going on as well.
You have to reflect.
Why? What do you mean?
Because it's.
Josie, what do you mean?
I don't know how to explain it.
Switches with the bottom.
Yeah.
What do you mean it switches what the bottom equation is? Because my x squared is still on top of my square root of x, right?
Well, but yeah, you're looking at like what's actually rotating on the outside.
Yeah, which is the one that's going to actually be making the bigger volume because it is further away this time? The square root of x, right? So you're correct. We would have to switch which one we're calling f and which one we're calling g. So I'd still go 0 to 2, but I would do the square root of x minus 5, and then x squared plus 1 minus 5.
I like that. That's cool.
Because the idea is, before we talked about f was the bigger function, right? But that's not necessarily true for volume. We want f to be the one creating the bigger volume, and g is the one taking volume away. So for that to happen, f is the one further away from my axis of rotation, and g is the one closer to my axis of rotation. And f is always first, right? So f is the one further away from my axis of rotation, and g is the one closer to my axis of rotation. Sometimes if I'm having a hard time figuring out which one is which, I like to, I draw this line a lot. I think it helps. Just draw a straight line from the axis of rotation down, right? And you can see which one is closer. Does that make sense?
Yes.
Okay, how are we doing, okay? Okay, so now here's your job, okay? I want a general formula. Given f is further away from my axis of rotation than g, and given my axis of rotation is at k, the number k, I want a general equation. So f is further from k than g is, and k is my axis of rotation line. Okay? So I want you to see if you can come up with a general formula that we could use anytime. So f is further away from k than g is, and k is my axis of rotation line. So use the ones we wrote on the board to help you with patterning.
Oh, yeah, that's fine.
I am confused.
Yeah, because, so, it's going to be minus 5.
Fair enough.
Because,
Fair enough. I did get that wrong. I don't have an answer to Fair enough. I still can't see what can I say?
Anyone willing to come up and write it up on the board?
I mean, I also can't.
Anna hasn't come out to work yet today. Middle table, crushing it today.
What can we say?
No, I don't know for a formula for the video.
right here.
Sure.
So which makes that technically bigger. I think so. That's why it's reverse sine. If you're arguing reverse sine, reverse sine.
Why is Anna minusing the k?
Because that's your shift.
What, Spencer?
That's your shift up and down, or up or down.
Okay, but if my y is -2, I thought we added. So, why is she minusing k in her equation? I've heard from you guys today. I want someone new. I want someone new. Why are we minusing the K? Does that work for both situations when I moved it up or down?
Yeah.
Why? I want a new voice. Why? Yeah, exactly. No, that's perfect, Kate. So when it's negative, it becomes positive. Because if what's happening is whatever my line is, if I want it to be 0, I want it to move opposite of what the number is. And the negative is what makes that, like the 2 negatives is what moved it up. Perfect. Yeah.
What if like the graph is already shifted up and there's a line below it but it's above the X?
One more time.
So if the graph is already if the graph does not hit 0 and so it's like up more and then the rotational line is still below the graph but it's still above 0.
Yeah, you always just want to move your K to 0.
Oh yeah, that
Yeah.
makes sense.
Yeah, does that make sense? Okay. Anyone else? Okay, go ahead and get out your ultra lavas.
I was trying to
Are we just writing all of that down?
Hashtag found it.
I really need to take a picture of this because
25 minus 26, negative 1.
it's true. But
Oh, yeah.
I left my backpack in my car, like wearing
Hey, take a minute or so, and I want that on your ultra lava. Yeah,
Can I just add something that Kate said?
please.
So the K would also be being subtracted because it's more distance between the K and f of x that isn't part of the volume.
More distance between K.
Like,
What do you mean?
it puts in like this distance which is not part of this volume.
Oh, that's a clever way to think about it too. Did you guys hear what Carrie said? She wanted to add just that if this distance between where the function ends and the K is, you don't want that part of the volume either, so it's taking that part away also. That's clever. And,
Do you want to see my salt?
okay.
I spelled it wrong. I spelled around. How much more stuff do we have to write on our ultra laws this year?
Quite a bit.
Uh-oh.
Well, I don't know about quite a bit. This right here is probably about the perfect amount of space to have left on the back. About half a page. Yeah, well, you need a whole column here for our integral rules, which are the opposite rules of this one, and then a little bit of extra space here.
I know one of them is the ln of absolute value of something.
Yep, that's close.
I got a debate. Just the biggest thing.
Oh, I'll just write them on.
No, yeah, it is. That's smaller than those two lines. Okay, well, that was 15. That's like half. And then this one's definitely. This one's definitely.
Once you get that down, I want you to use the region I drew over there and work with your neighbors. And I want you to find the volume of the solid made when that same region is rotated around the 2 different lines. And I want an integral expression representing it as well. Got like, I don't know, 5-10 minutes to finish getting this written down and then try those problems. least?
Yeah, but the one on the very bottom is not switching.
Oh, well, take it off now.
I tried it.
Want me to?
Granted, I was just trying to do it with my hands. Is it further or farther?
You gotta ask the Connections Academy.
Oh yeah, farther is like.
Farther means distance, further means more. No, I think that's the other way around.
Can you save me from
Look. Oops, sorry.
Can I touch it?
No, just throw it away. No. Yeah, it hurts. It's like a claw.
Yeah, do you see this?
Just touching it.
Do you see that?
hurts?
Okay. Have you ever had a cat or pet a cat that wasn't declawed? It's like having a rose thorn on the end of each of their
Thanks,
nails.
Thanks for that.
Yeah.
Oh yeah, that's right. Oh wait, I forgot to
Hey, see if you can combine these together. Our two ideas.
What's above the E?
X.
Y equals e to the x.
Oh, that's an X.
If it was just an e, then it would be a horizontal constant line, right?
I thought it was E to the plus. That was really
E to the plus?
Yeah.
Okay, I know my handwriting's bad, but that one I am not gonna own.
That one does. It looks more vertical than.
Yeah, I feel like inductive reasoning skills should have brought us.
E to the
Figured that one out.
That's why I asked.
Okay, James, okay. You guys are a very festive team today.
Look.
Wow, you're doing good.
Enter on that. Wait a second.
Uh-oh. Yeah, see, the plus doesn't make any sense. E to an addition sign? What is it?
What about E to the plus 5?
Because the plus doesn't make any sense unless you have a number in front of it and after it. It's an operator. It's something that tells you something to do between two numbers.
Yeah.
The example, there's two examples.
Okay.
Same region, just changing my axis rotation. It's a leaf and it's adorable. I don't know. Somebody came around and put them on all the desks.
Daniel, I have a good message for you.
Like when you have us figured out, I can't.
That's why you're in groups. I want to tell you nice things I know you can figure out.
My life is over too.
Yeah, everything else.
No, that's not what I meant. But don't you feel like you've gotten good, like this volume to visualize it and stuff? As soon as I got the scissors out, Taylor was like, yes, something. Okay guys, try these two examples, please.
Wait, I'm not supposed to.
Mrs. Summers, you are possessed.
I'm possessed? I thought you said possessed. At first, you did? That's what I heard. Chase, you are one in a melon. Well, some of these are good. You are legendary.
Oh my god.
Yeah, but think about it.
Hardest thing to draw out of all the dairy.
I know.
You could draw like a carton of milk way easier than I
Yeah, but that's a good doodle. I mean, but think about the people who did this. That must have taken forever. Like, how cute. You guys trying it?
You were thinking it.
I'm literally sad.
Oh yeah, okay. Well, let's process all of it. Zero cents because his music's like.
So picking that you put them in the wrong order. Oh, I already see what you did though. X equals negative 1.
The X is at Y. I mean, no.
Yeah, X1.
Still getting rocks.
That's enough for
What you did is more like to get your X's alone. Guys, focus. There's two examples. Chase. Says. Okay, try the examples, guys. Come on.
Yeah, that's what
Anybody want a hint for number one yet? Are you stuck?
No.
Maybe. I think I got it.
I'm gonna give a hint anyway.
Maybe I did.
It should have been dy
Yeah.
for number one because it's a vertical axis of rotation.
That's fine.
So you should have done a dy.
Number one?
I don't know.
Wait, you mean number two?
Number one is dy.
Oh yeah, because X
It's a vertical axis of rotation.
Oh, I see.
So number one, your integrand should have an ln in it somewhere.
Then I definitely did it wrong.
Definitely.
Because I did not use an LN. Okay.
Because when you get the x alone, it's x equals ln of y, right?
Yeah, okay, yeah, I totally just neglected that. Let me finish number two. Let me finish number two and then I'll get back to that.
What do you need, like 2 more minutes? 2 minutes?
Okay, so I did 2 minutes. Definitely did that wrong.
Intersection point is approximately 0.55.
Yeah, so we're trying to find the inverse of each
Bro, you gotta make the tail small. And then you gotta add a little eye. There, that's a little bit. You can also oh, you're not looking down.
Okay, it's right? Wait, does that mean this is gonna be?
What does that mean?
Inverse of
Hey, it's fine. It's starting to.
So I just go over the
Wait.
I had to zoom in.
So I didn't have a little brother. I tried to figure it out.
My windows like each one is such a negative one.
I was like, where's my graph? I didn't
That's what I want.
I remember.
I don't like it. Maybe it's not. I think it's better than Call Me By Your Name. Oh yeah. I don't think it's better than
Wait, so
That's what I want. I don't know, Old Town Road.
Yeah, I was gonna say, I'm like, I'm so caught up with that one.
I still think that's what I
Oh,
want.
it's good though. It's iconic.
It is like two.
I hadn't heard that song before.
So it's actually cool.
I love that. But all it's the exact same way. Yeah,
So it's where
you say my agree with her. Like, you know the song Off the Table? That's about it. And Love Me Harder.
Danny, 2 volunteers to go write what they got up on the board. Taylor, why don't you go right? That first one will work. That's okay. Just go right what you have.
I'll sit here just freaking heck. Wait.
I remember it.
I did this wrong. Oh my gosh.
Okay, I need you to yell it out.
Okay. Pi and then oh.
The
And
equation.
then it's the y minus 1 squared minus -1 squared minus, is this ln? Yes, ln y minus -1 squared.
Another parenthesis. There you go. That's good. Wait, hold on. Someone tell her the top limit of her.
It's 1.7. Yeah, 1.7. 46881.
And the bottom one, Taylor, should be 1, not 0. Perfect. Good. You guys see it?
Yeah.
Right? So she noticed that here, right? She got the x equals y minus 1 squared, and this is x equals ln of y, right? And then from 1 to here. Now hold on. Did anybody type this in?
Still he's working on it.
Oh.
Guys, we only have like 30 seconds left. I need help.
I got 0.689 for this one.
0.689?
Yeah.
And is this what you typed in?
Yes.
If I type this in, I'd get a negative version of that.
Oh, you gotta put the
So you either need to switch them or what's a quick fix?
one in the
Absolute value would be a quick fix too.
Absolute value.
Dude.
Yeah, the L and the Y should be first. That's what I was saying. Okay, I'm going to write this one up to 0 to something.
0 like 0.5.
Another nice thing
Okay, did anybody get the top intersection of this one so that I...
It's like sometimes I could be
558?
Do you have
And what was the answer? Anybody get it?
No, because I did the right. I just and then after I was like,
You guys, homework is from the book. I'll text it out in like 10 minutes, or you can get it from right there. It's all about rotational volume. And we move on to something different next time.
we love rotational volume.
Miss Summers, Michael knew it was up for the absolute value.
Dude, yeah, I called it.
Oh, really?
Yeah, I called it.
Good.
As the video.
Bookwork.
You can see us. I won't.
I'm confused when my calculator is yelling at me.
Okay, first thing, have you checked radians versus degrees?
Bye.